Hey everybody, today is the last day of the last section of this chapter. It's also the last video you will have to watch this year, so that's kind of exciting. In it, we're going to keep obviously working with similar triangles, but we're going to be talking specifically about the relationship between the ratios of the perimeters and the ratios of the areas of two similar triangles. So we're going to do a quick little exercise where we'll actually be able to figure out this relationship, and then we'll state it a little more formally. So here we have two triangles, right? Triangle ABC and triangle DEF. And the first thing we're going to do to check is to check and see if those triangles are similar. Now there's two ways we could do it. We could actually check for side, side, side because we know the three side lengths of both triangles, or we could look at side, angle, side because we have that included right angle. So either way we would do it is fine. I'm just going to check side, angle, side since that's the fewest proportions to check. So I'm going to check AC on this triangle corresponds to DF on this triangle. I'm going to see if that's the same ratio of BC to EF on this triangle. So if I were to reduce those, obviously they're both equal to a half, so those triangles are going to be similar. So now we're going to look at some ratios here. Remember, the similarity ratio is just the ratio of corresponding sides. And so we actually found that ratio already when we were checking our corresponding sides. So our similarity ratio is just going to be 1 to 2, or 1/2. Now, the perimeter ratio. What we want to do is we want to compare the perimeter, I'm just going to call it P, the perimeter of triangle ABC, and we're going to compare that to the perimeter of triangle DEF. So obviously to get the perimeter of triangle ABC, we're going to add the three sides together. So 3 plus 4 plus 5. And then for DEF, we're going to do the same thing. I have 6 plus 8 plus 10. So if I add these, I get 7 plus 5 is 12. Here I have 14 plus 10 is 24. And if I reduce that, I get 1/2. So what I recognize right away is that the similarity ratio and the ratio of the perimeters are actually the same number. So now we're going to check the area ratio. So I want to know the area of triangle ABC compared to the area of triangle DEF. Now since we have right triangles, we're just going to do 1/2 base times height. So I have 1/2 times 3 times 4. For DEF, I have 1/2 times 6 times 8. So let's see, 4 times 3 is 12 divided by 2 gives me 6. Here I have 48 divided by 2 is 24. And so if I reduce that, I have 1/4. Now, what I want us to recognize here is that 1/4 is just our similarity ratio, or our ratio of the perimeters, squared. Right? If I took that 1/2 and I squared it, I would get 1 squared over 2 squared, which is 1/4. And that's going to be the key to this whole thing. So here's the big idea. The proportional perimeters and areas theorem says that if the similarity ratio of two figures is, or I'm just going to generically call that A over B. So in our case, the similarity ratio is 1/2. Well, we know the ratio of their perimeters when we looked here was just the same thing. So the ratio of the perimeters is also going to be A over B. And then the ratio of their areas, right, it's just going to be A squared over B squared, which is the same thing as the quantity A over B squared. And this kind of makes sense. We know areas is a squared quantity. So we're just taking that same similarity or ratio of the perimeters and squaring that ratio. Okay, so now what we're going to do through the rest of the video is use the relationship that we just found between similarity, perimeter, and area ratios to solve for a missing ratio. And then we're going to use those ratios to solve for the perimeter and or the area of a figure. Okay, so let's go ahead and take a look at a problem. Okay, so it tells us that triangle RST is similar to triangle UVW. So they're giving us that information. They want us to find the perimeter and the area. So here's what we are going to do. The first thing we're always going to start with is the similarity ratio. I'm going to make a note here to start with the similarity ratio, because everything else is kind of based upon that similarity ratio. So in our triangle here, we have one pair of corresponding sides, right? I know that RS corresponds to UV. So I know that similarity ratio is 16/20, which if we reduce it is 4/5. So let's go ahead and first find the perimeter. So if I know the similarity ratio is 4/5, then I also know that the ratio of the perimeters is equal to 4/5. So here's where I'm going to use a proportion to help me figure out this unknown perimeter. So I'm going to compare the perimeter of triangle RST to the perimeter of triangle UVW. So now the perimeter of RST we're given, and we know that's 36. This is unknown, so I'm just going to call it P. But I know that ratio has to be in the ratio of 4/5. So now we just have a proportion to solve by cross multiplying. So I get 4P is equal to, let's see, 36 times 5, which is going to give me 180. So if I divide by 4, I get that the perimeter is 45, let's see, and our units are feet. So I know the perimeter is 45 feet. Sorry, that squashed at the bottom here. Now, I'm actually going to move over and use this space over here for the areas. Now, if my ratio of the perimeters is 4/5, I know that the ratio of the areas is equal to 4/5 squared. I have to remember to square that, which is 16/25. So now I'm going to compare the area of triangle RST to the area of triangle UVW. Again, I know the area of RST is 48. I don't know the area of this triangle. I'm just going to call it A. And that has to be in the ratio of 16/25. So now if I cross multiply, I'm going to get 16A, and then is equal to 48 times 25, which is 1200. If I divide by 16, I get the area is 75, and I have to make sure my units are square feet. So that's how we're going to use these ratios to solve for these unknown perimeters or areas. So I'm going to do the next one. It's the same problem. If you feel like you could do this on your own, I would encourage you to pause it, try it on your own, and then check. But if you feel like you need another example, go ahead and keep watching and doing this along with me. Okay, so same idea here. I have two similar triangles. I'm given a pair of sides on each, and then one triangle, I know the perimeter and the area. And again, my job is to find the perimeter and the area for the unknown triangle. So again, I'm going to start with my similarity ratio. In this case, I have the ratio of 13 to 9.1. It's kind of an odd-looking ratio, but I'm just going to leave it as it is. Now, I know the similarity ratio is going to be equal to the ratio of the perimeters. So I'm going to write down my ratio of the perimeters is just 13/9.1. So now I'm going to compare the perimeter of triangle let's see, LMN to the perimeter of triangle QRS. Well, for LMN, I know that perimeter is 36. I don't know the perimeter here, so I'm going to call it P, but I do know they have to be in the ratio of 13 to 9.1. So again, we're going to cross multiply. 13P is equal to 9.1 times 36, which is 327.6. And if I divide by 13, I get the perimeter is 25.2, and in this case our units are centimeters. Okay, now my ratio of the perimeters, or excuse me, of the area, is going to be the same ratio of the perimeters and the similarity ratio, so 13 over 9.1, but then I need to square that quantity, which means I take 13 squared on top, which gives me 169, and on the bottom I have 9.1 squared, which is 82.81. Okay, and now I go through the same exercise just using this ratio. So I'm going to do the area of triangle LMN, and I'm going to compare that to the area of triangle QRS. So here my area is 60. This triangle I don't know, I'm going to call it A, and then again I'm going to set it equal to this ratio, 169 over 82.81. And then I will cross multiply. Get 4,968.6, and then divide for my last step, and I get the area is 29.4 square centimeters. Okay. Now we're going to change up the problem a bit here. Really the only difference is that now we kind of have to draw in the picture. I always like to draw the two triangles. It helps me to organize my information. So let's see, I have two triangles, triangle ABC and triangle DEF. I'm not going to worry about drawing this to a nice scale. I just want to get these triangles down. So ABC, I don't know if one's bigger than the other, so this may be way out of scale, but it won't matter when we go to solve. So I have ABC and DEF are similar. It tells me BC is 4 millimeters, EF is 12 millimeters. And again, I can tell by my similarity statements that those are corresponding sides. Now, it's giving me the perimeter and area for triangle DEF this time. So it says P equals 42 millimeters, and the area equals 96 square millimeters. So now I just need to find the perimeter and area of triangle ABC. So again, we're doing the same process. Here we just had to get our information organized, so we use the correct ratios. Okay, so same as always, I'm going to start with the similarity ratio. So ratio of my corresponding sides is 4 over 12, which is 1 over 3. So now that I have that, I have the ratio of my perimeters. I know that's going to be the same thing. So that's equal to 1/3. So that's going to tell me that the perimeter of triangle ABC, the ratio of that perimeter to the perimeter of triangle DEF is, well, this perimeter is unknown. I'm going to use the letter P. Here my perimeter is 42, and I know that ratio has to be 1 over 3. So let's see, I get 3P is equal to 42, or perimeter is 14 millimeters. Okay, so now the ratio of the areas, I know it's going to be that similarity ratio squared, which is just going to give me 1 over 9. So now I'm comparing the area of triangle ABC to the area of triangle DEF. Okay, my area here on top is unknown, so I'm just going to call that A. This area I have 96, and I know that has to be in the ratio of 1 over 9. So I'm going to get 9A is equal to 96, which is going to give me an area of approximately, let's see, 10.7 square millimeters. Okay, so those are really the toughest problems, and everything should be pretty straightforward as long as you organize your work and make sure you have your proportions set up correctly. So now we've just got a couple quick questions left here to finish out the notes. So let's see. Now in this problem, we're given a similarity statement for two triangles, and they're telling us the ratio of the area of this triangle to the ratio of the area of the second triangle is 49 over 81. So now it asks us for the ratio of the perimeters of these triangles. Well, if I know that the ratio of the areas, let's see, the ratio of the areas is always the square of the ratio of the perimeters. So if I'm going to go backwards, then I need to take the square root of that ratio. So the square root of 49 over 81, which is the same thing as the square root of 49 over the square root of 81, or 7 over 9. So again, if I'm going from the area to the perimeter ratio, I just need to take the square root. Now that I have the ratio of the perimeters, I know that's the same ratio as the similarity ratio. So here I don't have to do any work. I just copy down the same ratio. So that is all of the new material for this chapter. We'll have a practice day, then a review day, and then your quiz will be on Thursday. All right, that's it.